How is my English? Easily understood? Good, thank you. As you can see, I've tried to start the presentation in Cyrillic. So this is my name. I've not seen my name written before in Cyrillic, so that's a good thing. So it's both a pleasure and an honour to speak to you today, and it's also especially important to me that I come here at this time, really to allow me to express international friendship between our various countries. And I'm very pleased to see that so many of my colleagues from the Postgres community have made it here as well, from so many different countries. So good to see you all, and hopefully we'll have many good conversations about some of the things that we're going to talk about in these presentations. So I'm going to talk to you today about PostgreSQL and the future. Obviously, before you give this kind of talk, the question of the future rolls in your mind. And I was in the taxi this morning, and as we got out of the taxi, the guy said, "Go straight, go straight." And I thought, that is remarkably good advice as a general thought as to how to approach the future. Completely wrong, as it turned out, but it turns out that the future is always more complex than you think. That joke was a test of how good my English is in translation as well. So, who's doing the slides? Ah, thank you. So, looking towards the future, the questions I ask myself is, what does PostgreSQL have? What doesn't it have? And how do we get there? How do we approach the future? So the first thing to say is that PostgreSQL 9.4 is very recently released, and it's got many new features, and of course it's very high quality software. And one thing that I do know is that most of you are not using this software yet. So the future is already here. You can implement new features in Postgres just by upgrading to the latest release. Now that's particularly important because Postgres releases a new major version every year. So if you're not upgrading quickly to the latest release, then you're not taking advantage of all of the good efforts that myself and the colleagues in the Postgres community, all of the efforts that they've put into producing new and good software. Obviously that's easy to say, and what you really want to know is what is the roadmap for the next 3 to 5 years. So, thinking about roads leads me to some important conclusions. We see in the road here that we have a slow truck in one lane and a fast car in another lane. And this, for me, reminds me of the way that software development works, because applications can be easily written. The cycle time of applications is very fast with agile development and DevOps. So we can implement solutions very quickly in application space, but when it comes to developing system software, the cycle time of new software is much slower. So new system software, like Postgres, moves at the speed of the truck, whereas applications and solutions for particular tasks moves much faster at the speed of the car. Now, in order to develop a software stack that works and quickly moves towards what we would like to see, I think that we need to think about things in a different way. But let me come to that. So my observation is that Oracle and Microsoft are developing system software on quite a long life cycle, a 3-year life cycle. And this, if you're trying to produce a solution for a particular business problem, then 3 years is like never, yeah? It's too long to wait. And so what we need to do in order to improve business processes is to reduce the cycle time by which we deliver new software and new applications. Postgres already does a very good job in that we have a cycle time of 1 year, but that is still too slow. I was speaking to some people yesterday who said they would like to have some software written into Postgres, but I said if we develop it now, then the software will be ready for you in September 2016. Okay, so this is too long, too far in the future, and we need a different way of delivering solutions for people to use. So what I think that we need to do is we obviously need to avoid traffic jams. We need to have more developers working on Postgres, and we need a smoother development process. We're already thinking about this. This is a work in progress. But one of the things that we really need to do is think about having more lanes on the highway itself. So the slow lane is for the database kernel, and the fast lane is for applications, but the middle lane can be provided by database extensions. So what I'm saying here is that what extensions can do for us in Postgres is allow the database kernel to be delivered as a very high quality, a nice tight piece of system software, but then many different additional features and solutions can be provided by extensions. Now I'll explain this some more. So Postgres in the last couple of years has added a large number of new features that are specifically designed to allow you to extend the database. We've invented something called background workers that allows you to have your own processes running within the framework of Postgres. We have dynamic shared memory, dynamic locks that allow access to that shared memory. And we've implemented a number of different APIs that allow us to extend Postgres so that it's not just a single monolithic piece of software, it's actually a much more complex piece of software. And there are more features in development to allow us to extend Postgres. So why is this important? Having extensions allows us to go at 2 speeds. We can have a very high quality database kernel while at the same time having extensions that provide a whole range of new features to people. And having both changes to the kernel and extensions allows Postgres to move faster towards particular solutions than our competitors. Okay? So it's the extensibility of Postgres that allows it to quickly adapt to new challenges, new solutions. And this, I see, is a very important aspect within Postgres. The extensibility of Postgres is highest of any database system available. So the extensibility of Postgres will allow us to adapt to the future. So what I hope will happen with extensions is that we're able to develop one version of an extension, improve the extension some more, and then improve it again. And then when the extension is very high quality, we're able to include it within the core distribution of PostgreSQL. So we have a high rate of change in the development of new features before they're included within the database kernel. Okay? I hope I'm expressing this thought clearly. It's a complex thought, it's a new thought, but what I'm trying to say to you is that the extensibility of Postgres is the central feature that will allow Postgres to become the best database for your solutions. So what am I really talking about in terms of solutions? You'll see that there's actually a very wide range of new extensions available within the Postgres ecosystem. We see BDR, which is new mechanisms for replication and data transfer. PG Audit, which allows people to record access information to allow you to run a properly secure system. PG Rewind is also a mechanism for replication. And these features on the right are all features which are designed to improve the performance or the scalability of Postgres. And you'll see that PG Strom and some other similar extensions will allow us to use GPU processor technology to enhance the performance of Postgres. We can see things like PG Shard, which is designed to improve the scalability of Postgres, and I know that there's a talk on that later in the conference. There's also some sampling extensions being produced, and of course, if you haven't heard of it already, Vodka is going to be an important new indexing technology that will be brought to you by your local team. Good name. So what we see is that Postgres is not just simply a database. It's not a single piece of software. It's actually a framework for delivering components that allow you to build a solution for your data. So one of the phrases I used some years ago was a data operating system. And I see that the Hadoop people have thought that's a good phrase. I'll use it as well. So I thought, okay, I'll go back to describing it as a data operating system. I've also described it as a rich data platform, thinking about the same way that Eclipse is put together. But the idea is that the future is not a single piece of software, it's a collection of related system software that will allow you to build a complete solution. So what I'd like to do now is just tell you a little bit about some of the extensions that I know the details about. Okay, so there's something that we've been working on called BDR. I've got 3 slides on this, but I've got a whole talk on this tomorrow morning where I can go into more detail about how this works. So this is really just an example of the types of features that you can now get as extensions within the Postgres framework. So BDR gives you something called unidirectional replication, and this is also known as logical replication. It allows us to copy data from one database server to a second database server. And that works as a plugin to the 9.4 release. So we are just about to announce that in the next couple of weeks, but we already have some working versions. It's just we've got a slightly improved version coming in a couple of weeks. The main product that we have is bidirectional replication. So this is a full implementation of multi-master replication that allows you to have servers in many different cities, all with fast access to the data. And a country like Russia quite clearly has need for data in many different places. Now, the implementation of multi-master that we have gone for here is probably the most complete that you will see anywhere in the industry, because we have included within it things like transparent global sequences. So you can use a sequence and it just works. We've also included within that DDL replication. So you can make changes to your database and they will be pushed through to the other nodes. So we're not just talking about multi-master replication as a basic technology, we're talking about it as a very advanced feature that has very low management overhead. So what we've been working on for UDR for 9.4 is logical replication that includes a couple of extra features, which is selective replication. So you can specify particular databases or particular tables to replicate. So we've implemented something called replication sets, which is something that came to us from the Sloaney tool. We've also implemented the ability to edit the data that is replicated. So, for example, you can replicate inserts but not deletes. Now, that's a very technical way of describing it. A more business way of describing it is to say that this feature allows you to have a data warehouse next to your operational system. And what that allows you to do is it allows you to ask many different business questions to allow you to improve your business processes. So this feature, described in a technical way, sounds kind of complex and weird. What is that? But it has a real business benefit that we will see in the years ahead. We also support online upgrade. So when we get to 9.5, you will be able to upgrade to 9.5 fully online. Now, somebody said they don't like the word online upgrade, the phrase online upgrade. So what I will do is I'll change that to zero downtime upgrade. That is an important feature. So what we have within the Postgres software stack is a slow climb upwards towards greater functionality. We had some attempts here with Sloaney and also with physical replication and hot standby, but there were limits to these directions. So what we have done is we've completely rethought the way that replication needs to look, and we're building upwards from this new direction. So we have logical replication, and on top of that BDR, and eventually on top of that we will be looking towards massively parallel distributed systems that are able to scale to improve the performance of our database applications. So normally when I give this kind of presentation, I list some new features that will be coming in later releases. But I am very pleased to say there are too many good features to list. What I would like to do is just describe to you that there is active work progressing in all of these different areas. Each of the lines here is one major area of software development that is being progressed within the Postgres community. We have a major push towards more business intelligence features and the performance of queries within a business intelligence situation. Production systems, online processing is also being improved. Quite surprisingly, we've improved Postgres performance more than 100 times in the last 7 years. And there is more performance to be gained yet, and we're pushing forwards in that area. There's a lot of work, and you'll hear many talks today and tomorrow about scalable Postgres and what we're doing to push forwards in those areas. But behind the scenes, there are also many additional features being worked on. Improved operational capabilities to allow the database to stay up longer and to work with less maintenance. Also features that will allow us to expand databases beyond small numbers of terabytes up into the tens and the hundreds of terabytes. We're also working on improved application diagnostics and control features for applications. And probably one of the most important things that we are working on is what I will call reduced overhead schema evolution. What is that? Well, in recent times, the NoSQL databases have proposed that we should write applications using what they call schemaless technology. And I think this is something of a confusion. They have proposed schemaless technology because there is a cost to making your applications work correctly when it has a well-defined schema. And so the job for Postgres is to reduce the cost of using a full and correct schema for your data. We are also implementing many things like JSON-B that allows you to have schemaless if you would like it, but we don't force you to have it. So I've called that project Reduced Overhead Schema Evolution. So you can see that what we're trying to do is make the systems that we already have work fully and correctly. But all of this development is very important because the most important thing about all of these features is that they are attracting new research and development onto the Postgres platform. Postgres is the database that has been mentioned most in academic research papers. There's a lot of interest in the Postgres source code, and that brings new people, new ideas, and new funding into the worldwide PostgreSQL ecosystem. So Postgres is already the best database, it's just that not everyone uses it yet. Now, if you think that that's a kind of marketing hype, what that slide used to say is Postgres will one day be the best database. And one of my fellow developers looked at it and said, oh, it's not already. And I thought, okay, I'll take it up a notch and say that Postgres is already the best database. So what I've said to you today is that Postgres's future is because of the ability of extensions to evolve quickly to new solutions. But one of the core underlying parts of Postgres is that the open source software allows us to work together. So wherever we are in the world, wherever we live, wherever we choose to live, we are able to work together across the internet to produce good software. So when people write good software, we don't look at the software and go, oh, that guy's from Russia, that guy's from India. Yeah? Everybody's ideas are equal in the Postgres community, and it doesn't matter where you're from. Okay, I mean, obviously there's many people, you can't tell by somebody's name. I don't know if you've realized, but I'm English. So, but I could live anywhere. I could be Australian, I might live in Chile. You don't know, okay? And that's the beautiful thing about the open source Postgres, is that it allows us to work together across countries, across languages even. There are a great many people that work on Postgres that don't speak English as their first language. In fact, I think it's probably only about 40% of the community that speak speak English, speak Postgres as their first language, speak English as their first language. And I was mentioning to somebody earlier that this idea that we need to move to Silicon Valley in order to produce good software, that's just wrong. I have once been to Silicon Valley, I think, but not very often. We have this thing in London which they call Silicon Roundabout, which is kind of trying to be a hub for software development. And I'm sure that you've got the same things here. But the reality is that good software development can be done from anywhere in the world. I wonder if Oleg can help me. There was I've forgotten the surname of the man that wrote the write-ahead log code, Vadim. Yeah, yes. And where did he live? Novosibirsk? Okay. So he was able to contribute to the Postgres code base without needing to travel to Silicon Valley. And that is really the true strength of Postgres, is that it's got an international development group, and as a result it's got a truly international user base. And so what I'd like to leave you with is the thought that the reason that Postgres is the best and will stay the best is that it is inclusive. It allows everybody to contribute and to benefit from Postgres. I'm going to finish a bit early. Is that okay? Do you want me to carry on for a while? Or? Okay. So, let's do one thing. If you are interested in me talking about some more technical features, please raise your right hand. Okay, that'll be a yes then. So, cool. Okay, so what I'd like to do is just go back to some of these development themes and give you a more detailed insight into some of the things that are happening in each of these areas. So business intelligence in the 9.5 version of Postgres, we have a new feature called a BRIN index, or block range index. And what this is, or what this was designed to be, is a form of auto-partitioning. So you build this index on a table, and it acts almost like you built partitioning onto that table. So you're able to improve the speed of a sequential scan. We have some improvements to the hash join technology that will be coming in 9.5 that look to improve the speed of hash joins, I think by about a factor of 2 increase in speed. So what we've measured recently from 9.2 to 9.5, the current version, for business intelligence, it's 200% faster already, the version that we currently have in development. So what we're saying is there's going to be a huge leap forwards in business intelligence performance. Now, not only that, there's been a lot of work done on parallel query as well. Now, 9.5 will not contain what I'd call a full implementation of parallel query, but it's coming in the future. We've put all of the hooks in there that will allow that to happen. And I probably should have completed my code review of that before coming here, so I could tell you more about it. But the code for that's looking pretty good. In terms of CPU scalability, I know that there's been some work done on atomic locking, which has improved the performance for high numbers of CPUs by 200 to 300%. That's 200 to 300%. Okay. So what I'm saying there is that on a system with 8 quad CPUs, so that's effectively 32 CPUs, we've been able to considerably improve the performance. In terms of 9.4, 9.4 contains a particularly important feature, which is write scalability. We've improved the access to the write-ahead log that allows us to improve write performance on each node by around 60%. And one other feature to talk about in 9.4, which some people haven't made much note of, is the reduction in lock strength for certain alter table commands. And that's the first part of this reduced overhead schema evolution. So the unidirectional replication is particularly important because the performance of the replication that we have with UDR is approximately twice as fast as the previous trigger-based replication. And we've been able to do that because we avoid the use of triggers in collecting the data, and we also avoid the use of re-executing the SQL on the far side. So this type of replication that we have is much faster than the previous generation of technology. It's much faster than Sloaney, and it's much faster than MySQL standard replication as well. Okay, so I'm going to end a little bit early, but I would like to say thank you very much for the opportunity to speak to you today. If you would like to speak to myself about features or about second quadrant, we're here for 2 days, I'm very happy to speak with you, and thank you very much to Oleg for suggesting that I come here to talk about Postgres futures. So if there's no questions, then thank you very much.
Ну, Саймон, как всегда, зажег.
Like always, Simon was the best. And when I was thinking whom to invite from international Postgres community, I didn't even doubt. And I wrote to Simon asking, would you like to come and tell us about the prospects? Because every time that I listened to Simon, and I did it many times, he managed to burn the flame in the eyes of technicians. And I believe that now that you have listened to this great speech, you understand that Postgres is a good database, and we are all in for a sweet future. What I would like to ask Simon...
Quadrant and the logo. But I have a question. What does it mean, and do you think that this logo is correct? Because the second quadrant should be...
Certainly, yes, that's a good question. A lot of people ask that. So the meaning of the second quadrant is twofold. There is an analyst company called Gartner, which talks about the positioning of technology, and the upper right quadrant is what they call the magic quadrant. So the position of this refers to the idea that our work, Postgres, is in the magic quadrant, so that implying that we have the ability to execute and the vision. But the real meaning is that is a deeper meaning, and it's to do with your character and the way that you approach problems. There's a book called The 7 Habits, and in that book it describes that the second quadrant is the way of thinking about problems that are important. So the second quadrant reminds us to work on important tasks, not just urgent tasks.
Спасибо, thank you. But I thought that the second quadrant better suit Russia. This is position, it's Russia.
Oh, well, okay.